as per usual, even though people still don't know what I'm doing. So we're going over the quiz prep today, 3 of them. They'll finish up 2-3, get a start on 2-4. The quiz prep 2-1, 2-3, which is what your quiz is going to be based on, is going to be posted today. Thursday, we'll go over 2 questions from that quiz prep. We'll continue, basically try to finish up 2-4, 2-5. Next Tuesday, we'll go over the quiz prep. Anything else you want to see? Make sure chapter 2 is complete. You get the review sheet for chapter 2. Next Thursday, instead of the test, we're reviewing. So that gives us a little bit better of a buffer before the test on Tuesday the 5th. So Tuesday the 5th. Okay? So it was pushed back. F1 for solving. Always, no matter what. Follow the steps. You got to simplify first. Simplify completely. If there are fractions, undo the fractions. Well, we don't have any fractions, so we're going to simplify. Both sides. On the left, inside the parentheses, those are not like terms, so you can't do anything with 3x minus 10, 25x plus 12. You can't add until you multiply 12 into this parenthesis. So you're going to distribute. Then we're going to bring down from left to right. Work the problem from left to right, and then bring it down right underneath. Every step along the way. Be organized about it. And you know what? We'll back up one step. Or not one step, but one half of a step here. Before you do anything, look at the entire problem and have a plan. Think about what you do before you actually do something. You hear that, before you say something, think about it. Try to think. Think before you act, think before you talk. Think. I know it's we don't always think. I don't always think. Sometimes when I'm sitting in a meeting with an administrator, I don't always think before I talk to them. That's bad sometimes. Sitting with family members, I don't think before I talk. Tension. Come up with a plan. Think about what you're going to do. What you have to do to solve this. Make some choices. Lay out your game plan in your head before you actually do anything. You know you have to solve it. So you know you have to simplify. You know right here, you can't do anything until you distribute. So I got to distribute it. And I got to remember to write it down from left to right. And not just work this side, but just keep working all the way across. Over here, you're going to distribute -7. So it's not a surprise when you come across it. You're going to think about from left to right, everything. You cannot subtract 15 minus 7 because you have to multiply before you would subtract. So you're going to distribute -7 into this parenthesis, and you're going to write down the next step right underneath it. So you want to establish your idea before you actually act upon it. Bring down 25x. And then positive 12 times 3x is positive 36x. And then positive 12 times negative, so it's going to be a negative. 12 times 10 is 120. Equal. Remember, 15 minus 7 does not happen because you have to multiply first. So bring down the 15. -7 times positive 2x is a negative 14x. And -7 times -6 is negative times negative, positive 7 times 6, 42. That's just one Simple step, one step at a time. Make your steps simple. Don't try to do too much all at once. Small bites, but organize from left to right. Bring it down from top to bottom. Now a little bit over there, a little bit here, a little bit down there, and then try to put it all back together. We're still not done simplifying. So we're not going to go to step 2 where we try to get x on one side, constant on the other. Clean up this side. You have 2 terms with an x in it. 25x plus 36x. That is equal to 61x minus 120. Equals. It should be better to work on gathering up your x's first, and then the constant, x and then the constant. So you establish some kind of organization. It doesn't matter, but negative 14x, and then 15 plus 42 is positive 57. Now, if you put 57, make sure you put minus 14x. Either way, these are the 2 things I have on my right-hand side. Either a positive 57 minus 14x or a negative 14x and a positive 57. Either way. Now, step 1's done. Left side, right side, both cleaned up. Simple. Now go to step 2. Now remember, I did emphasize this. Gather all your variables on one side, then put your constants on the other side. Gather your constants on the other side. Focus on the variables first. So we either take the variables to the right, you would have to subtract 60, and this is where you start, think it through. Subtract 61x from both sides, so you end up with negative 14 minus 61, or bring the variable to the left, so you'd have to add 14x to both sides. Focus on the variable. So do we want to bring it to the left or take it to the right? So we want to take it to the left. So we're going to add 14x to both sides. 61 plus 14 is 75x. Now, when you do this step, if you don't put the x with it, they're not like terms. I cannot add 14 to negative 14x. They don't go together. It has to, if I'm going to bring this negative 14x to the left-hand side, to undo negative 14x, you have to add 14x. These details matter. I still have minus 120 equal to 57. So if we brought the x's to the left, we're going to have to undo this negative 120, take it to the right. So we add 120 to both sides. And we have 75 times x equal to 177. And you divide both sides because it's now multiplication. We undo multiplication or division. Divide both sides by 75. So x is equal to, simplify your final answer to lowest terms. So maybe this reduces. Well, 177 over 75, they're both divisible by 3. This is equal to 3 times 59. This is equal to 3 times 25. So the final answer is 59 over 25. Reduce it to lowest term. It's on every quiz, it's on every test. Reduce final answer, simplify the lowest term. Now I'm gonna write the bonus two right up here. But I don't want to mess up the other side. I'm gonna erase this top part. $64 times X minus 40 times Y is equal to 104. You're supposed to figure out the slope and the Y-intercept. And the only way to get it from here to figure out the two pieces is you gotta solve for Y. We want Y equals mx plus b. Because the slope is the coefficient of X, and then the constant is the Y-intercept. So you gotta solve for Y. I'm putting this as a bonus question because it was that question that was missed by too many people. First question on the test. So if I want to solve for Y, I want Y all by itself on the left-hand side or any side. So I'm going to leave this negative 40Y here, and I want to take the 64X to the other side. So I have to subtract 64X from both sides. So that means negative 40 times Y equal to, and again, X and then a constant, so negative 64, X and then plus 104. Separate Y from everybody else. And now we want to solve for Y. It's being multiplied by negative 40. So you divide all the terms. Each individual term gets divided by negative 40. Every term gets divided by negative 40. And then you reduce. If it can reduce, you reduce it. There's Y equal to a negative over a negative will be a positive. 64 is 8 times 8 over 40 is 8 times 5. And then I have an X plus 104. 104 is 8 times 13 over 8 times 5. And I got a mistake right here. It's positive 140 divided by a negative 40. 104 divided by a negative 40. So a positive over a negative, I should have made this sign change. A positive over a negative is going to be a negative. So I end up with Y equals the H reduced 8/5 times X minus the H reduced 13 over 5. So slope, Y-intercept. The slope is the coefficient of the X variable, so it's 8 over 5. Not the X. X is not part of the slope. The slope is just the M. If you put an X there, it's not part of the slope. So I've been circling it, and I say no X, and I take off 1 point. And then the Y-intercept is the constant. It's a negative 13 over 5. Undo what's being done to the Y. We're just solving for Y, which is the same premise over there on B3. Bonus number 3. Undo what's being done to the height, to the H. The volume of a pyramid is equal to 1/3 times the area of the base, which is XY. 1/3 X times Y times the height of the pyramid, which is H. So what is the formula for the height? What is the formula for H? What is H? So here's X, here's Y. The area of the base is the area of X times Y. The height goes from the top vertex of the pyramid straight down, it's perpendicular to the base. There's the H. So the area of the base, X times Y times H, and we take 1/3 of it. And that's the volume of that pyramid. So all we want is H. Step one. For solving an equation, step one, simplify both sides completely, because there's a little extra piece to it. Starts with, and 4 letters starts with a U. Undue fractions. This thing has a fraction in it, 1/3. So what's the common denominator we can multiply by to get rid of that fraction? 3. You don't like fractions? There's a fraction. Undo it. So if I multiply both sides by 3, then I get 3b equal to X times Y times H. No more fraction. So I'm solving for H. So I want H on one side, everybody else on the other. Done. You can't put X, Y on the other side yet, because when we do that, we're talking about adding or subtracting the X and taking it to the other side. The last thing we do is undo multiplication or division. This is X, Y times H. So the last thing we do is divide or multiply. And that's what we're going to do. But we're not going to add or subtract the X, Y, because this is multiplication. And H is being multiplied by X and Y. So we divide both sides by X and Y. So the X is reduced and the Y is reduced. And all you have over there is just H. And over here, that you can't simplify it. It's 3 times the volume over X times Y. So the height formula is 3 times the volume divided by XY. That's all I want you to do. What's the formula for the height? It looks menacing. Where's my numbers? I mean, if I want to plug something in, just solve for something. But no, just undo what's being done. Just like solving for Y. You give me this, get Y by itself. Undo what's being done. Same steps. Simplify both sides, undo fraction. Separate your variables, undo multiplication or division. Not going to change. So we're going to continue with the examples from 2.3. We did 11 last week. So we need to do ready 15, 30, and I added 4 of those. Red. So the good news. Nothing has changed in terms of how you do things. You follow the order of operations. Parentheses first. Now, what has changed is what you're going to simplify. What you're going to do with those order of operations. So what we did last Thursday. Simplifying radical. Number one, no perfect n powers left inside an n through. No perfect squares left in the square root. No perfect cubes left in the cube root. No perfect fourth powers left in the fourth root. This chapter, we're going to be focusing on squares. No perfect squares left in the square root. If you can simplify a square inside of the square root, you need to simplify. For example, the square root of 12. Here's the rule. Square root a times b is the square root of a times the square root of b. So you have to actually know the perfect squares. Well, has a factor of 4. So this is the square root of 4 times 3. And now I can separate that product into this square root of 4 times the square root of 3 and the square root of 4 is 2. So when I simplify the square root of 12, I get 2 squared root. You cannot leave a perfect square inside that square root. I posted this last week. You may want to make sure you know some of these. The more you know, the easier it's going to be. Definitely for this chapter, knowing the column of your perfect squares is. As far as you can go. Definitely through at least through 25. The more you know, the better you're going to be. If we had the square root of, let's go with 224. Now, square root of 225, that's a perfect square. That's 15, if you know your perfect squares. But 224, you got to know what perfect square might go into that either. So here's a different, here's an alternative way to do it. And I already, went over this with the Cobra. I'll make sure you guys get a chance to hear it. Square root of 12. What if you don't see the 4 times 3? What if you only think of 2 times 6? Well, 2 times 6, nobody's going to break out because neither 2 or 6 is a perfect square. But what you can do is make a factor tree. You see, this square root is like a jail. And to break out a square root jail, you need 2 of a kind. So if you decide to break this apart with a 2 times 6, then if you keep factoring 2, and then 6 is 2 times 3, when you have 2 of a kind, those 2 2s can make a run for it. Now, here's the sad tale about jail. When they make a run for it and they're climbing over the wall, only one is going to make it out alive. The other one's going to get shot and killed. So one of those two survived. The other one is gone. This 3 has nobody to break out of jail with, so he's got to go back in the cell. So 2 squared 3. So if I cannot think of a perfect square that goes into 12, I can still break them apart. I can think of any 2 numbers. It means even, I can divide by 2. Like this one's even. This is 2 times 112. It's still even. This is 2 times 2 times, that's 56. That's still even. This is 2 times, that's 2 times. This right here is 2 times 28. So that's 2 times, that's 2 times, that's 2 times, that's 2 times 14. So that's 2 times, that's 2 times, that's 2 times, that's 2 times, and that's 2 times 7. It's a factor tree. When you have a factor tree, bring all the branches down level at the bottom. Because if I don't bring that 2 all the way down, and I'm trying to figure out how many 2 broke out, or tried to break out, I'm going to forget about that 2 at the top. So you want to bring all the branches down to the bottom. In other words, don't be lazy. So here's a pair of 2s. They make a run for it. 1, 2 makes it out alive. Here's another pair of 2s. 1, 2 makes it out. They meet up on the outside. When they meet up, you multiply them back together. How do they break apart in the first place? We factored it. We factor it, it's division. So when they meet up, you multiply them back together. Now, the 2 and the 7 don't have a pair. So when they go back in their jail cell, 2 times the 7 is what you have back in the jail cell. So what actually broke out of jail was a 4, and inside, back inside of the 14. Which means this 224 is actually the square root of 16 times 14. 16 goes into 224 14 times. But I would need to know that 16 was the factor of the perfect square that goes into the 224 in order to do this, in order to do this, in order to go like that. As long as you show me the work and you don't just go from square root 224 to this, you show me how you get there, we're all good. Work must justify your answer. Okay. So no perfect nth powers left inside of an nth root. The second rule, and this is going to become important when we get to 2.4, 2.5, and at the end of 2.3. No fractions left inside of a radical so if we have the square root of 25 over 36, you can't leave a fraction inside of a radical. So the property for radicals, if you have the square root of a over b, we can split that up into just the square root of a over the square root of b. Take the square root of each one. So I can rewrite this as the square root of 25 over the square root of 36, and that's a 5 over a 6. But I can't leave the square root of 25 over 36. I got to simplify. If I have the square root of 1/2, I would have to rewrite this as the square root of 1 over the square root of 2. The square root of 1 is 1. And what's the square root of 2? What time? That's it. It doesn't simplify. I don't have 2 of a kind that make 2. But rule 3 says no radicals left in the denominator. So there's a term for that. You have to rationalize the denominator. You have to rationalize the denominator because this right here is violating that rule. Right here, it violates the rule because it's a fraction, rule 2. You can't have a fraction inside that square root. So we split it up. So we don't have a fraction inside the radical anymore, but we have a radical inside the denominator. We can't have it. We have to rationalize it because square root 2 is irrational. I want a rational number down. It's a square root. How many of a kind do I need to break out a square jacket? I need 2 of a kind. I have 1, 2. So how many more 2s do I need? 1 more 2. So I'm going to multiply by 1 more square root of 2. But if I multiply the denominator by another square root of 2, I change the problem. So I have to multiply the numerator by a square root of 2. Because whatever I do to the denominator, I got to do to the numerator as well. Because what's square root 2 divided by square root 2? What? So I'm not changing anything. But what I'm going to change is what the answer looks like down here. In the numerator, 1 times square root 2 is square root 2. In the denominator, lots of things can be done. Square root 2 times square root 2 is the square root of 2 squared, because there's 2 of them. And if you square a square root, it undoes the square root. If I multiply square root times itself, we just get the 2. Or square root 2 times square root 2 is the square right here. If I go this way, square root a times square root b is just the square root of a times b. So this would be the square root of 2 times 2. And the square root of 2 times 2 is the square root of 4. What's square root of 4? 2. So whether you want to go square root of 2 times square root of 2 is the square root of 2 squared, and the square undoes the square root of 2 to the answer, or square root of 2 times itself. We have 2 times 2 on the inside, square root of 4, which is 2. Or how about this? Since I'm multiplying by square root of 2, the whole purpose is to undo it. It's exactly the same, so I know I'm going to square it. You go straight to there. You don't need to show that you're going to get a square root of 2 squared, so it's just 2, or you're going to get the square root of 4, so it's just 2. We know that it's going to be just a 2 because you're squaring. That's the whole purpose. I square a square root, it undoes the square root, out pops the 2. But now we're perfectly fine. I don't have a fraction inside of a radical, and I don't have a radical down in the denominator. And inside that square root of 2, that's simplified. all the rule of thumb. And then when we did Thursday, we had the square root of negatives. When we dealt with our complex numbers. The standard form A plus BI. So it's a real number and then plus B times the imaginary. So the real part and the imaginary part. You treat I just like a variable. There's a few things to make sure we have it down. I to the first is just I. I to the second power. Do you remember? -1. -1. I to the third power. Negative I. I to the third can be rewritten, and so we have I to the first, which is just I, just like anything else to the first power is itself. When we have I to the second power, here's what happens. Since I is the square root of -1, when you square both sides, I squared, the square root of -1 squared. We square the square root, the square undoes the radical, it undoes the square root, and we just get the -1. So I to the second, that's why it's a -1. When we do I to the third, we can rewrite I to the third as an I squared times I. Because when we multiply, you add the exponents. So this would be I squared times I to the first, 2 plus 1 is 3. I squared is -1 times I to the first. So that is equal to -1 times I, which is -I. I to the fourth. I can rewrite I to the fourth as I to the second times I to the second. +1. So it's going to be +1. I to the second is -1. This is -1. -1 times -1 is equal to +1. So when we have an I to the fourth power, it equals +1. Refresh me from my memory. Did we do these powers? We did not. Okay, so I'm doing it now. I to the fifth. Because here's the goal. You're going to have to do something like I to the 3,800. Oh, let's go with 63 and simplify. So we've got a long list to make. I to the fifth. But here's the good news. I to the fifth can be rewritten I to the fourth times I. I can rewrite things all day long. Rewrite. No wonder I told you to do things like rewrite stuff. What's I for? 1. So 1 times I is just I. I to the sixth can be rewritten as I to the fourth times I to the second. I to the fourth is 1. I squared is -1, and 1 times -1 is -1. Do we have any predictions about I to the seventh? 1. -I. I to the eighth. positive 1, I to the 9th, right? I, because there's a pattern going. I, negative 1, negative I, 1. I, negative 1, negative I, 1. I to the 10th, so it'll be negative 1. I to the 11th is going to be negative I to the 12th is going to be 1. And I guess you just keep on going, just on the
It's something except for I squared.
So I is defined to replace square root negative 1. That is I's definition.
Oh, okay, that's.
So then we square each side. We get negative. But when we have the square root of the negative, we poke out that. And we use I as a symbol of square root. How many in the pattern? How many does it take for a repeat? 4. There's 4 in the pattern. So all you have to do is you take the old exponent and divide by 4. You take the old exponent and you divide by 4. The remainder is the new power. So 3,863 divided by 4. Now 4 can't go into 3, so there's nothing in the thousands place. So we go over to the hundreds. 4 goes into 38 9 times. I get 36. 100. We subtract. And we get 263. So now we're looking at this from the tens place. We're looking at 26. 4 goes into 26 6 times. And that's 240 from the tens place. And then we subtract. And we get 23. So from the ones place, 4 goes into 23 5 times. And that's 20. And then we subtract and we get a 3. 4 can't go into 3. Back in the good old days, that was called the remainder. So this is 4 goes into 3,863 965 times with the remainder of 3. The remainder is the new power. This I to the 3,863 is equal to I to the third. And I to the third is now negative I. That's the final answer. Divide by 4. The remainder is your new power. Now we got to understand something. Remainders. You're never, ever going to get a remainder of 4 when you divide by 4. Because if you get a remainder of 4, you should have gone in one more time. You're going to get remainders of 1, or a remainder of 2, or a remainder of 3, or a remainder of 0 because it went in evenly. But that's okay. If it went in evenly, it's just this. I to the 0. One of the rules of exponents. Oh, been keeping this a secret all semester long. Rules of exponents. Did I ever talk about these? Did I mention the rules of exponents before ever? Yeah. Anything to the 0 power, even I to the 0 power, is 1. So if the remainder is 0, I to the 0 is 1. Okay? So when you divide by 4, you're either going to get a remainder of 0, which is 1, remainder of 1, you divide, remainder of 2, I squared is negative 1, remainder of 3, negative I. Okay? Rules of exponents. I got recess. Sorry, not sorry. Okay. So, complex numbers, when you simplify radicals with negatives, if you are simplifying, let's just do 2 up here. Let's use the square root of negative 50 versus the square root of negative 300, I guess. Step 1, poke out the eye. Or poke the eye. So I know the answer has an I in it. And then focus on the 50. You can now ignore the fact that it's a negative and just focus on the 50. Simplify the radical. So 50, whether you go 2 times 25 or 10 times 5, you'll get the same answer. 2 times 5 times 5. A 5 breaks out, and there's a 2 left behind. If I would have gone with a 50 and went 2 times 25, well, there's a 2 and 5 times 5. A 5 breaks out, and there's a 2 left behind. I really want to make sure that you understand. Please put I between the constant, the coefficient, and the square root or the radical. In the back of the book, they will put it as 5 square root of 2 I. And it will look like the I is underneath the square root. But it's not, nor will it ever be. And if you write it like this, it's going to look like you wrote it underneath the radical unless you're really clear and neat about it. So you're going to be safer if you put it in between. Treat it like a variable. Don't put it in front of the 5. Put it between the square root, the radical, and the coefficient of product. So here, poke out the I. And then 300 is just 3 times 100. So that's 3. We got 10 times 10. Now here's the good news. You don't have to keep going. You don't have to break that down into 2 times 5, 2 times 5. You have a pair of 10s with only a 3 left behind. So 10 I with a square root 3 left behind. You can keep going if you want. If you didn't choose for the 100, you didn't choose 10 times 10. For the 300, you didn't choose 3 times 100. But you chose like 50, 6 times 50. I don't know why. You did. Not everybody's going to choose the same thing. So now, number 15. Negative 8I minus I squared. The order of operations. Negative 8I minus, before I can subtract, I have to do this exponent. So negative 8I minus, what is I squared? Negative 1. So parentheses minus a negative 1. Because I'm going to subtract the negative 1. So what's that going to become? plus 1. If you leave it like that, it is not going to be full credit. Because the directions mandate, stipulate, tell you they want the answer in standard complex form. And that's going to mean they want it A plus BI. So the real number should be first. The real number is the 1, positive 1, and the imaginary number is a minus BI. So it has to be written in the way the problem is stated, just like on a test. Real number than imaginary. You know, I give partial credit. But unfortunately, for a problem like this on a test, the mistake that gets made way too often gets no partial credit. Because as I'm about to do right now, as I will do when we go over and review for the test, I will tell you, please don't do this. Pay attention to the question. Think about what you're going to do before you do it. What do you think causes trouble here?
Yeah.
What do you think that somebody might do that shouldn't be done? What do you think?
Oh, do the order of operation.
Well, that's always important. What does this question ask you to do? But that's the way you know those are the steps you're going to do it with. Well, what's the overall question? What are we supposed to do overall? Well, wait, that's what we're going to simplify, but what are we simplifying? What kind of question is it? Compare it to number 42. What kind of question is 42 versus number 30 right there? What is it? It's addition. That's an addition problem. We're supposed to add. Number 42 over here, we're going to multiply. But you know what happens as soon as people see parentheses, I'm multiplying. They ignore the fact that it's addition in between. And they just took a really simple problem and adding a simpler than addition, multiplication. And they made it incredibly difficult. And they're not going to get any credit because they didn't do the question that was asked. Because they didn't pay attention to the question. Where were you on the night of January 32nd? And they start saying, well, I was at home. How could you be at home on a day that doesn't exist? You didn't listen to the question. So it's addition. Think about the problem before you actually start it. It's just add. And regardless of the question, you will always simplify first. You always got to do what's in the parentheses. Simplify radicals no matter what, because it's going to make your life easier. Okay? So this one right here, we have 7, and then we have a plus. We're going to poke out the I. 18, it doesn't matter if you go 2 times 9 or 3 times 6. So I'm going to go 3 times 6. And that is 3 times 3 times 2. So a 3 escapes. So that's 3i with a square root 2 left behind. 7 plus 3i squared 2. Plus, in this parentheses, we have a 3. We have a plus. Square root of a negative, so we're going to poke out the I. 32 is 16 times 2. 16 is 4 times 4 times 2. There's a pair of 4s. So a 4 will break out, and there's a 2 left in the square root. 4i squared root 2. Now, in the parentheses, you can't go any further. You can't combine 7 with 3i squared root 2. They're not like terms. You can't combine 3 with 4i squared root 2. They're not like terms. So we can drop this parentheses. 7 plus 3i squared root 2. Plus this one, there's nothing here. If it's addition, the signs won't change. If it was subtraction, distribute the negative, all the signs do change. So plus 3 plus 4i squared root 2. And now you combine the like terms. 7 plus the 3 is a 10. And then you have 3 of these I squared root 2. And then another 4 of the I squared root 2. These are like terms. There are 3 of those I squared root 2s and 4 of the I squared root 2. The variable part and the radical have to be exactly the same. The variable, whatever the letter is, and the radical part has to be the same. If this was 3i squared root 2 and this was 4i with a square root 3, you could not combine them. Because what do you get when you combine square root 2 with a square root 3? You get square root 2 plus square root 3. You cannot add them together. Okay? You cannot combine unlike terms. So 3 of these I squared 2s plus 4 of the I squared 2s is 7 of those I squared root 2s. Before you do anything, you always simplify. Simplify radicals before you multiply. So I want to simplify square root negative 6. The only thing I can do with it is poke out the I. And I don't have 2 of a kind. It's 3 times 2, and that's it. So square root 6 stays behind. It's I squared root 6 times square root negative 2. So I'm going to poke out the I. And there's only a 2, so I don't have 2 of a kind. It's square root 2. So now I have I squared root 6 times I squared root 2. I'm just going to rearrange it so you see how this multiplies together. The multiplication property, the commutative property of multiplication. A times B can be rearranged, and we can do B times A instead. So I'm going to rearrange this square root 6 and I. So I can go I times this I, and then I have this square root 6 times that square root 2. I traded places, like Eddie Murphy and Dan Aykroyd. Trading places. That's Christmas movie. Yeah. You know who Eddie Murphy is?
Yeah.
Vacation.
Yeah. I times I is I to the second. Square root 6 times square root 2 is the square root of 6 times 2 on the inside. So that's the square root of 12. We're not done. I squared is what? -1. Square root 12 is 4 times 3, which is 2 times 2 times 3. A 2 breaks out. A 3 left behind. The square root of 12 is 2 square root 3. So we have -1 times 2 square root 3, -2 square root 3. You have to simplify first. Whether you see it or not, this is just like x minus 2 times x minus 3. It's just distribution, FOIL. Inside the parentheses, simplify if you can, and they're not like terms, so you can't. So we distribute. I'm going to write this out. We have a 6 times a 2, so 6 times a 2, and then 6 times a positive times a negative is going to be a negative. 6 times 3. So we're done with 6. Now we're going to distribute this -2i. A negative times a positive is going to be a negative. That's 2i times that 2. And then we have a negative times a negative. This was tricky. This part right here, definitely. Negative times a negative is going to be a positive. This is 2i times 3i. That last part's always tricky. I'll tell you why in a minute. Or about 45 seconds. 6 times 2 is 12. Minus 6 times 3i, that's minus 18i. Minus 2i times 2, that's minus 4i. The reason why this last part is tricky, when we distribute, a negative times a negative is a positive. But when we multiply this together, 2 times 3, that's a plus 6, I times I, you get an I squared. What's about to happen there at the end? So what? It's going to be a -1. We're going to end up with a 6 times a -1 because I squared is -1 always. And you have to simplify completely. Your answer should never have more than an I to the first. Because I squared is a -1. I to the third is negative I to the first. And I to the fourth would be a positive 1. And then it keeps repeating. So the only power you never have is in I to the first. So we have 12, -18i, a -4i. That makes -22i. And watch what happens here. Positive 6, I squared is negative 1. 6 times negative 1 is minus 6. So you have two more like terms. 12 minus 6 is 6. So 6 minus 2i times 2 minus 3i is equal to 6 minus 22i. Now, 42 and 44, if you know your special products, you might be able to do these pretty quick. If you know that a plus b squared is a squared plus 2ab plus b squared, if you remember that a minus b is a squared minus 2ab plus b squared. And you really want to know that a plus b times a minus b is a squared minus b squared. If you know your special products, you should be able to get to, going to be 18. And this is going to be 9 minus 40i. That. Now, I should never do those in my head because I always get them wrong. So I'm going to work this out. 42. I'm going to embarrass myself. Square root 3 plus I square root 15 times square root 3 minus I square root 15. There's a special name for this problem. It's a difference of two perfect squares. It looks just like the last special product. It's a plus b times a minus b. And the only reason why is because the first term are both the same. This is a, this is a. They're both square root 3, the same thing. And then the last term, I square root 15, that's an I square root 15. They're both the same terms. They're both the same first term. They're both the same last term. The only thing that's different is one's plus, one's minus. And when we multiply this together, we get a squared minus b squared. Always the difference in two perfect squares. So the answer is going to be the square root of 3, a squared, minus I square root 15 squared. A squared minus b squared. If you decide to go ahead and FOIL it out, distribute, we get square root 3 times square root 3. And then a positive times a negative is going to be a negative. And we get square root 3 times I square root 15. And then we get a positive times a positive, so that's positive. I square root 15 times square root 3. And then we get a positive times a negative, so that's a negative. And we get I square root 15 times I square root 15. Square root 3 times square root 3 is the square root of 9. What's the square root of 9 going to be? 3. Or you can look at it as the square root of 3 times the square root of 3 is the square root of 3 squared. And if you square a square root, it undoes the square root, you just get the 3. Look at what happens in the middle. Minus, this is I times square root 3 times square root 15 is the square root of a 45. 3 times 15 inside is the square root of 45. And then this one is a plus I square root 15 times 3. That's a square root of a 45. Look at what you got. Negative I squared 45, positive I squared 45. What do they add up to?
They cancel.
They cancel out. They add up to 0 because we're not going to have a middle. That's what happens when you multiply these right here. There's no middle term. It becomes 0. And then we have minus. I times I is going to be an I squared. And then square root 15 times square root 15, that's the square root of 225. So we have minus, what's I squared? It's a negative 1. And what's the square root of 225? You haven't looked at that list yet? 15. Negative times a negative is a positive, so that's plus 15. So this is 3 plus 15, which is 18. Minus. This whole parentheses is getting squared. I is getting squared. And if I square the square root of 15, I just get 15. Because when I square that square root, it undoes the square root. So I end up with 3 minus an I squared. That's minus a negative 1 times a 15. So that becomes 3 plus 15, which is the 18. It's impossible to get it wrong unless you're making it up as you go along. If you decide to FOIL it out, or if you decide to use the special product, make sure you know how to use it. One step at a time. If you're not getting it right because you're doing too much in your head, then write out each one and take it slower. Five minus 4i squared, a plus b or a minus b squared. This is a minus b, perfect square of a difference problem. So we square the first term minus multiply the first two terms, or multiply the two terms together and double it in the middle, minus 2ab, and then plus we square the last term. Or FOIL it out. This is 5 minus 4a times 5 minus 4a. 4i. Whichever way to get it right. So if I square the first term, I'm going to get 5 squared minus 2 times a is a 5, b is the 4i, plus B is the 4i, we square the whole thing, 4i, whole thing squared. If we go this way, I times 5, 25. 5 times a negative is a negative. 5 times 4i is 20i. And then distribute the second term. Negative 4i times 5 is another negative 20i. And then last times last, negative times a negative is a positive 4i times 4i. 4 times 4, 16. I times I is I squared. Five squared is 25. 2 times 5 is 10. 10 times 4 is 40. So minus 40 with an I. Plus 4 squared is 16 times I squared. It's 25 still. Negative 20i, another negative 20i is negative 40i. And right here, 16, what is I squared? Negative 1, 16 times negative 1 is minus 16. We have two like terms, 25 minus 16 is positive 9, minus 40i. And over there, you have 25 minus the 40i. And then 16 times negative 1, which is minus 16, 25 minus 16, 9 minus 40i. So the work, everything's fine. Know which one you're going to go. Think about it before you do it. This is what's on your quiz next Tuesday. $48, $56. Okay. What we're doing in 48 is so we can do number 58. Everything about 48 is to be able to do number 58. The directions on 48. Write the conjugate of the given expression and then multiply them together. So what a conjugate, it's exactly the same term except the sign is opposite. In other words, this is what we want for conjugates. A plus B and A minus B are conjugates. Exactly the same two terms. An A and A, a B and a B, but one's a plus, one's a minus. So since this one's a plus, the other one's a minus. If this was a minus, the other one would have a plus in between. When you multiply them together, it's the difference of two perfect squares. That's the goal. That's what conjugates are. So if this is 3 plus 5A, the conjugate is 3 minus. You say A. There's the doctor. It's 3 plus 5I. This is 3 minus 5I. We know one, we know the other. And then when you multiply them together, because they're conjugates, because it's A plus B times A minus B, you can use the special product, A squared minus B squared, or you can FOIL it out. Whatever you decide to do, practice it. So you're really good at it and you don't make a mistake when you do it. So if I use a shortcut, or not the shortcut, but the special product, 3 squared, and then a minus, parentheses, because you're going to square all of it, the 5I squared. So maybe put this in parentheses as well. So the 3 gets squared and the 5I gets squared. Or if you decide to distribute, 3 times 3 is 9. And you know the middle is going to be 0, but if you're not convinced, positive times a negative is a negative. 3 times 5i, 15i. Positive times a positive, that's positive. 5i times 3, that's a 15i. A positive times a negative is a negative. 5i times 5i. 5 times 5, 25. I times I is I squared. So either be really good at just distribution or know the special product. 3 squared is 9. It's still minus. You square everything inside. 5 squared is 25 times I squared. We have 9. These two cancel out because they make a 0. And this is negative 25 times negative 1. So what does it end up equal? Plus 25. 9 plus 25 is 34. Over there, we get 9. Minus 25, this is negative 1. Negative 25 times negative plus 25. 34. All right. Number 56 and 58 are in violation of our rules of radicals. I don't see a radical. Well, remember, I is the square root of a negative 1. I is a radical. It's a square root. We simplified it. It's an I. But you can't have I in the denominator. You can't have a square root in the denominator. So we have to rationalize it. If it's just an I, that's a nice one because I showed you how to rationalize 1 over square root 2. 1 over square root 2. We just needed another square root 2 to rationalize. That way we have a pair of square root 2's. So the answer was a 2 down there and square root 2 up above. On 56, negative 5 over 2i. The 5 is fine. The 2 is fine. The troublemaker is I. You can't have I in the denominator. So to rationalize the denominator, I have to undo the I down here. I need another I, just one more I. I squared becomes negative 1. So I need an I squared. If I multiply the denominator by I got to multiply the numerator by I. So I have a negative 5i over 2 with an I squared. So that's a negative 5i over 2 times what's I squared? Negative 1. So this negative though, negative 5i over 2 times negative 1 is negative 2. This is a positive or a negative? What is it?
Positive.
5i over negative 2. What is that? It's a negative. A positive over a negative is a negative. So this is a negative times negative 5i over positive 2. And a negative times a negative becomes a positive. So when you simplify this one, it's positive 5i over 2. When you look at this, what's the plan? Oh, okay, I can't have I down here, so I'm going to multiply by I over I. I. Multiply by I over I. So I have 5i down here, I squared. So what does that become? So what does that mean? Negative on the outside. Got to keep bringing that down. A negative times a negative becomes a positive. If you don't rewrite the things correctly, if you leave something behind, that's what messes up your answer. And if you're not neat about it, I got to go looking through a mess of where did you make up to make the mistake. Try to find the partial credit. The neater you are, the easier it is for me to find the partial credit in case it's wrong. And then 58 lets us down. 58 lets us down completely. Three over 1 minus I. Okay. You can't have an I in the denominator. So the last thing we did was we multiplied by I over I. If you do this, it ain't gonna work. If you just try to do what we just did, I over I, we get 3i. Now down here, it's I times the entire denominator, so you would have to distribute. So you get I times 1 minus I times I squared. So we end up with 3i over I minus negative 1, so that becomes plus 1. And you still have an I in the denominator. You didn't undo jack. So multiplied by just an I is not going to undo when you have a binomial. If it's a monomial, it works. A single I, one term, one thing. That'll work. Binomial needs the conjugate. That's where it comes in. To undo the binomial, when you have an I or a radical, we have to multiply the numerator and denominator by the conjugate. So if this is 1 minus I, what's the conjugate of 1 minus I? 1 plus I. So I'm going to multiply the numerator and the denominator by 1 plus I. This is on the 2-1 to 2-3 quiz prep. It's not going to be a quiz question. It'll be a bonus question. Now, there's going to be, I'm throwing a lot of potential bonus questions at you. Doesn't mean you're going to get every single one that I'm talking about. So when I say bonus question, we're talking potential bonus question. But it is going to be a test question. Simplify this. In the numerator, 3 times 1, 3 times positive I, so plus 3i, over in the denominator, we get 1 times 1. And if you do this underneath, you're going to go ahead and FOIL it out. We get 1 times 1, 1 times positive I is plus I, negative I times 1 is negative I, and then you have a negative I times a positive I, negative I squared. These two cancel out, so you have 1. What happens with negative I squared? What does I squared become? Negative 1 minus a negative 1 becomes plus 1. So you're going to end up with a squared, 1 squared, minus b squared, minus I squared. So 3 plus 3i, all over 1 minus negative 1. So 3 plus 3i over 1 plus 1, which is a 2. Simplify it if it can simplify. If you can't simplify it, you're done. That won't simplify. That's a done deal. However, in the back of the book, here's what you also want to get used to. When we hit the 2.4, 2.5, you're going to have to simplify answers that might look like this. Let me give you an example. Something might look like that. And you always have to reduce the lowest terms. So you either have to factor out the greatest common factor and reduce it. The biggest number that goes in 12, 15, and 24 is a 3. So you would have to show that you can factor out a 3. So this would be 3 times 4 plus 5i square root 6 all over 3 times 8. And then the final answer would be 4 plus 5i square root 6 all over 8. And you cannot go any further. No, you do not reduce the 4 and 8. Because if you reduce it, it has to go into everything. Or if you want to play it safe, split the fraction. Separate the fraction, reduce each fraction separately. 12 over 24 plus 15i square root 6 over 24. See, I can split this up. 4 over 8 plus 5i square root 6 over 8. 12 over 24. Well, this is 12 times 1 over 12 times 2. I can reduce the 12s, I get 1/2. Plus, this is 5 times 3 over 8 times 3. I can reduce the 3s, so I'm left with a 5i squared 6 over an 8. This is 4 times 1 over 4 times 2, 1/2 plus 5i square root 6 over 8. I don't care how you do it, as long as you show me how you did it. if you go from here to there and you don't show me what you did, you don't get full credit. Because I think it's not possible to go from the answer to your final answer without showing how you did it. You can't just go, okay, that goes into that, and you get a 2. Because if you go ahead and reduce this without factoring, how does the 15 reduce if all you have is a 2 left over? You reduced the 24 already. You don't just go crossing things off. Factor first and then reduce, or split the fraction and reduce each one. So right here, it doesn't reduce because you don't have a common factor between the 3's and the 2. Or 3/2 plus 3i over 2. This is how it's going to be in the book because they want a plus b I. Standard form. 73, remember the one where we divided by 4 and we did the remainder? That's 73. Okay. You're going to get the quiz prep for 2.1 and 2.3. Now, we didn't talk about 2.4, but that's going to be our big day on Thursday. I'll finish it all, everything up on Tuesday next week, get the review sheet, review for the test. On Thursday, our quiz on 2.1 to 2.3 is next Tuesday. The test is the following Tuesday. Make sure you read and take a picture of that if you need it. If you were late, you better see me. If you need your test and stuff back,